Hi and welcome to another episode of TRX Bench. Today I have here a nice Yaesu, so it is the FTM-400, and this radio came in with no transmit on VHF and UHF. Well, you know, this radio is known a little bit for getting very hot during transmission, and well, let's see if this radio may have been killed by a heat problem or if there is something different. So let's have a look what's really happened to this radio. And of course, this is no unboxing video, so let me quickly prepare it for our first tests, and then we see what's really going on here. Alright, so here is our setup, and yeah, it is receiving, but that was of course not the complaint. So we are more interested in, is the radio able to transmit, and that is what we want to test. And what we can see so far is that here our transmission bar is lightening up, so the radio is obviously switching into transmit, which is good. So let me see. Setup. No, that is wrong. I'm looking for output power, and yeah, so TX power is switched to high, and we can switch it to low. We see the bar is not going so far. On mid it is not full, and on high you see now our bar is fully on the right side, which is telling us, so it is switching here without any problem. Yeah, we are on our high setting, and I read on high 380 milliwatt. Yeah, what we can see here, so it is jumping a little bit, but basically you see that is the maximum power on UHF. So let me switch the radio to VHF. Let's see what we get there. There we get obviously 7 watt, but it is also our high setting, which is of course not right. So let me double check here. If I go down to low power on VHF, yeah, it is 1.5. So by the way, you can see our transmitting frequency on the left display, so 145/500. So that is setting on low 1.5, and on mid we have 6, and on high, where we should see 50 watt, we see approximately 7 watt. So of course that is not good. Okay, but before we go ahead and cracking off here our radio, let us do a factory reset, which we can perform by pressing display for more than 1 second, and we get our setup menu, and there we find reset and clone, of course what we wanna press, and you see here the different reset functions we have. What we do is a factory reset. to be really sure that old settings which might have been done are reset to factory. And then let's do another test to see if that does something. Okay, so factory reset, and of course I press OK here, and you see it is resetting, and now it is completed. And you see asking me putting in you know, a call sign. I just want to go over, and now we can set again. Okay, so we can still receive, which is of course good. And now let's check if we can transmit. We can, but still we do not get our full power out of it. So that means we really need to check our radio more in depth. Okay, so here's our radio cracked open, and yeah, we looking here on at the main board, but there is only the main board, so everything is here on one PCB. And yeah, under this shielding here we have our power amplifier for VHF and UHF. And well, so first what we're gonna do is we taking off here the shielding to get here a better overview. And then well, we need to think about how to start. Okay, so I've loosened here the screws around, and we had to undo here one solder joint where the shielding is soldered down here to the PCB. And now we can really lift off here our shielding, which we have done now. And well, look at that. Look at that. So as far as I can see it, I really would say that this power amplifier has been swapped out before, so that is what it looks like. And so obviously not the first time where something was wrong here with transmit, as we can clearly see. So it looks really that it looks like that really the power amplifier has been swapped, so we can clearly see it here on the solder work. And well, if now this amplifier died again, which we do not know up to now, but well, so we really have to take that into account. And when I'm looking here at the chassis, we have our fan here, and the fan is blowing here onto our chassis here to cool it down a little bit. But the FTM-100, I believe, I'm not wrong, has more or less the same chassis. Some little differences, but basically the same. And there we have here holes or a cutting, I don't remember exactly, where, you know, a better airflow is given. So here, I mean, okay, I mean, the whole housing here is the heat sink, and this little fan here is trying to cool it down, help to cool it down. But you know, I believe it is, as I was guessing before, that it might be a heat problem, because this is definitely no good. So, well, but let's go ahead a little bit and let's see if really our amplifier is dead, or if there is something different which is or was failing in this case here. Okay, so really the first what we could do is testing if our voltages, our supply voltages is there, and if the switching voltage is there, and of course what's about our bias voltage for our MOSFETs, because the power amplifier itself is a double pack MOSFET amplifier, and then we have here our driver, right, and which is of course a MOSFET as well, and under our ground lead here, this here is a pre-driver, which is a MOSFET as well. That means finally we need our drive voltage and our supply voltage. That means that here we should read our supply voltage, which is the drain of our power amplifier, right? And at the gate, so as it is a dual pack, we have here a gate and here a gate, we should read our bias while we are transmitting, and the same we have of course here at our pre-driver. At our output, so that means drain, we should read our supply voltage of 13 something, and at our gate we should read our bias, and of course the same we have with our pre-driver, and that is of course now the first we will check. Okay, so this way we should be able to see both. Okay, so the first is our plus B, which should be always available, and it should be here at our drains, and as you can see 13.6 volt, that is fine. And at our gates we do not have nothing in the moment of time, because we need to press our PTT. But let me first of all check our supply voltage at our driver, which is here, and you see that is given as well. Okay, then next will be our supply voltage at our pre-driver, which should be present there. And yeah, you can see we have our 9 volt, so the pre-driver is sitting on a different supply voltage, which is 9 volt, and that means all our supply voltages are given. When I now switch into transmit, we should be able to read our bias voltage. So we start at the gate of our pre-driver. So let's see, I press, of course, I press PTT, and we see 1.0 volt, which looks not too bad. Unfortunately, we do not have any informations about what we should read, but 1 volt is not too bad. Let me check what we have here at our driver, which is sitting down here, and there we have 2 volt, which looks fine, no problem whatsoever. Now we do exactly the same here at our 2 gates at our final. And okay, let me test it, and we are pressing, and it is plus 323 millivolt, which looks a little bit low. 324. Okay, so what is on the other gate? On the whoops, what is that? On the other gate we have nothing. Once again, this one, it is 323 milli. But on the other gate there is nothing, absolutely nothing. So because you know, the bias will be supplied from the same source, so maybe that is a first indication that we have here a short, right, on our MOS-FET. So let me check where our bias voltage is coming in, and then we can exactly test that point, and then we know if, for instance, our whole bias voltage is dropping at here a resistor, and thus we have a short here on our second MOS-FET. But yeah, let us have a look into our schematic. Okay, so let's start here with our transmitter section. And yeah, so this here is our pre-driver, this is our driver, and here this is a dual package of our final. So let me zoom in here a little bit more, that it is easier to see for you. And yeah, so you can see here our both gates, gate 1, gate 2, and we were able to read here 300 millivolt at G2 and nothing at G1, which could be a short to ground, so that our complete bias voltage is dropping here at our resistor package here. And if we follow here this line down, yeah, let me go down, you see that down here from our power control, so this is our automatic power control, if you like. So here we set our wanted output power, low, mid or high, and then if we get a positive voltage here to this comparator, then you may see that this runs here over our Q150, which is closed by our TX voltage, which is getting here to our Q100, it's not 150, it's 1508, by our double pack, and you see down here, so this is the transmit voltage for UHF and VHF, and positive voltage here on this digital transistor means that our base of this PNP transistor is pulled to ground, which is telling me that here our voltage from our power controller is bringing our bias. You can see it here, right? You can see here that power control can get into it, right? And yeah, so that simply means if our power at the power amplifier is reached, then here our IPC line is putting here a positive voltage to this impedance converter, and that is sending a positive voltage here to the negative input of this comparator, and that means it is pulling the voltage here completely to ground. So that is how it is basically working, and that means that the output power will be reduced until the point where this comparator is switching back, and then it is always switching back and forth to hold our output power. So that is yeah, automatic level control or automatic power control. However, it is cold, and yeah, I'm really wondering why we do not read here at gate 1 you know, bias. So something must be wrong. I need to check where our here's our switched voltage, which is finally delivering, as far I can see it here, is delivering the bias controlled by our APC. And yeah, let me see where we are losing finally our bias here for this dual pack of MOSFET. Okay, so the resistors for testing the voltage drop are underneath, and that means I cannot get an access to that resistor, so we do it a little bit different. Also, this is not always the best, as we do not really know what's all around our component. But we just have it here on diode test mode, right? And if we go here from our gate to ground on the good one, you see that is fine. So there it is still open, so there is no short, everything fine. So now we do exactly the same here on that one where we were not able to test for bias voltage. We do exactly the same, and that is a complete short in both directions, and that is telling me that we really have a bad short here on our final. And ground drain is also shorted, but now that is always a little bit critical to test it in circuit, because we do not really know what might be in between. But this is a very good indication if the one we were able to test our bias and the other one is shorted, so that should not happen. And that is what I thought, that the voltage drop is on one at the resistors in front of the gate, and thus we do not see our voltage as gate is shorted to ground. And that means, yeah, our MOSFET is definitely dead. So again, why is it dead? I still believe that it is a temperature problem. I believe that even under normal conditions this is running really hot until the point where it simply breaks. And so we really need to think, if we do a modification here on the chassis, as I told you, on the FTM-100 we have here holes which is helping to get a better airflow, and I believe that has something to do here with our problem. Okay, what we can do to be sure that our driver is working, so we can do a short test with the scope, and if the driver is fine, so the next will be, we have to take out here, of course, our PCB, and we need to get here our component out of the circuit to finally go ahead. Okay, so this way I hope you can see everything we need. Okay, radio is still receiving, as we can clearly hear. And yeah, so now let me test here our voltage, our driver input voltage. Let me see if you can see it, and here it is. So what we can see here, 145 megahertz, so with approximately 950 millivolt RMS, so that is gate, so input, and we know that our radio is working on the right output frequency, and here our frequency counter is confirming it, so that is right. Now what we are doing, we are testing at the output of our driver. So let me go down to the output and let me, oh yeah, so we see that it is really amplifying here. So it is 2.6 volt output at 145 megahertz. So we can clearly see that our driver is working. And when we do the same here with the final, I believe we can see here our input signal with 2.6 volt, and the same at the output, and you see 2.4, so it is reducing the output signal. So that means here our double package is not completely shorted, but one of the double pack MOSFET is shorted from gate to source, and that is resulting in the fact that the radio has no power amplification, and that means now we have to take out here our PCB. Okay, and that is what we have done. So our board is out of our chassis, right? And of course our final is out right here from the board, and I've already cleaned here our solder pads that we will be able to solder in here a new one, and still we have the short between gate and source, which is then definitely the proof that here our final stage is gone. So unfortunately I have not this component on stock, so I have to order it, but yeah, that should not be a big deal, so I have to put it aside and wait for our new final stage. Okay, so back to our FTM-400D. It is now 1 week later, and I received finally here our new amplifier for our blown one, and that is what we're gonna do. So we have to put it in, and let's see if the radio then will work again. Well, in the meantime we did a little modification to our chassis. So according here to our chassis, it is a FTM-400DE, right? And I mean, this radio is still in the market, so you can buy it, but it is not longer a FTM-400DE. Now you can buy it as FTM-400XDE, and that is a modified version. And well, we did pretty much the same. So you exactly see what we have done. So we opened here the chassis, that we get a good airflow through the unit, right? And that is what the X version has. So there is now here a complete hole in the X version, so to get good airflow through the unit, and I still believe that that is the main reason why these amplifiers are dying. My body mate did all this mechanical work, and yeah, I added here some sequences how we did here this modification. So if you like, you can watch it. If not, simply use fast forward.
We measured a distance between the ribs of the heatsink of 4 millimeters, and therefore we are drilling 3.5 millimeters.
Okay, so before I now put in the new amplifier, I have fixed here the board with 3 screws, so that is only to have the board right in position, because let me take here the old one. When I put it here back, I need to align first of all here our amplifier and then tuck it down here to minimum 2 points here, just to have it aligned, and then I take it back out to solder it finally in. Because if I have it in the circuit, then I have the whole heatsink here, and the heatsink of course is pulling down my solder iron temperature, which leads to the fact that we really need to solder very, very long, and that is not good for our component, and that could be a potential problem for the future, because if you heat it much too long, then even if it works after you have soldered it, it might have an internal damage already, which will result in a early breakdown. So it is really essential to keep the soldering time as short as possible, and therefore when we have tacked it down, we take it back out. Okay, before I place now my new chip, I put here some flux to the board, because these are the points I'm able to solder easily in. And now I can grab here the amplifier, and of course, very important to have the right orientation. So always make sure that you have it in the right way here, lying on the board. Now I put here my screws in, because that will give me finally the right alignment to the board. Otherwise you are really in trouble. So if you have soldered a component like this down to the board, and afterwards you recognize, oh, I can't get my screws back, then believe me, you are in trouble. Okay, so now that is prepared so far, and now I really tack this and that maybe to the board, and then I take it back out. Okay, so you see I've tacked these both pins, and now I take the whole board out to do the rest. Okay, so all is prepared, and I can go ahead with soldering, and that is exactly what I'm doing now. Okay, so our amplifier is in, but let me tell you, don't underestimate the ground plane. So you really need to do it very carefully, and you need enough power from your soldering iron, because if your soldering iron is too weak, then you will fail. So the right heat, the right power of your iron, and of course a little bit experience is very helpful, because this is tricky, believe me. Okay, now we put it here back in the chassis, and then we can go ahead. Okay, and we have here another little tricky detail. So you see this ground clip, and this clip here will connect both ends. I mean, so far it is not really an issue, but if you look carefully here onto our amplifier, you see here, so this here is a solder point, right? And here underneath we have solder, so we need to tuck it down here into the middle. And that is another little tricky thing, as you already can imagine, we have all the ground plane, and we have to do it in a chassis. So this is a little challenge to tuck it down here on the board, on our power IC. So first I will clean it here a little bit, put some fresh solder, and then I try to tuck it down with high temperature and a bigger solder tip, because that is key here, to have a good solder tip for transferring here the heat, because as already said, we really do not have too much time not to destroy here our new IC. Yeah, sometimes the easy things sucks a lot, but yeah, let me try to clean it first a little bit and to get here the lead-free solder off here our little metal, and then I hope we will be able to get it here back on our radio, right? Okay, so I hope we can leave it this way. And now let's try to go ahead. Okay, so we place here some flux onto this ground point, and now we try to get here our connection, our ground clip over it. So let's see. Okay, now I have to put here the screws. Oops. Yeah, that is how it goes. So let's try to do it this way, and of course our second one. And yeah, this all is really time consuming, and but it doesn't make any sense to rush here. And additional to that, really it needs its time. So if you rush, you definitely destroy it. And now, yeah, I have the same problem as I had already with soldering here our complete chip back into the circuit. So I really can't do it around the camera. Sorry. So that is really impossible. Sorry, I have to do it. Off camera. Sorry for that. Okay, so just done. Yeah, it is important to say, to get it soldered in, you really need enough temperature. Even with a solder iron, which has normally enough power, right? But I increase the temperature when I'm doing work like this. So normally I work on 355 degree centigrade. Doing jobs like this, I increase it for this job to 375 degree C, and it is important to say that you should use here a tip like this, really to be able to have enough heat transfer, and then it will work. But still it is tricky, and you really need to be careful. Okay, all is back so far. Here are copper and the antenna connector, and now I have to put back here the plastic front, and then we are almost ready for testing. Alright, so everything is connected. Communication tester is connected, power supply, everything is fine. So let's fire it up and let's see what's going on here. Alright, so it is firing up, and yeah, looks like that we have received, let's see, and we have, that is very nice, but that is not the most important issue or point. We just want to know if we have transmit, of course, because that is the reason why the radio was in. Okay, so let's see, TX power. We should not start with high, so let's go to low. Okay, let's see if it in general transmits. And here it is switching. It is showing here our power bar, which is fine. So let's see what the output level is telling us. Alright, so here is the tester, and the upper right display is showing the output power when I'm keying here my PTT. Can we see it? Maybe this way. So radio is set to low power, and let's see. And here we are, 4.25 watt. Great, and our output frequency seems to be fine as well. And even on this distance I see that we have deviation, so that is working. Okay, so let me go to medium power, which is dialed in right now. Let's do exactly the same, and 17 watt. Great, so that is working as well. And of course let's switch to high, and it is set to high, and let's see what we have. 45 watt. That is great. And of course, so the radio is rated for 50 watt output power, but you know, I do not like to push these radios like hell. I really like to do it a little bit carefully, because you really can overheat your system. And you know, therefore I really like to take it a little bit back, and therefore 45 watt output power is just fine. If you're talking over the radio, your distant end partner will not recognize if you're transmitting with 45 or 50 watt, but believe me, this 5 watt is really doing a difference for your power amplifier. Okay, so what we have to do now is we have to check it on 70 centimeter, of course, and I'm just do here my preparations, and I've set it on 430-100, and I set it on low, and let's see what we have. And we have 388 on low, which is fine, and you see on the left upper display, so that is our frequency for 30, almost 100. It is not completely warm. Anyways, let's go to medium power on 70 centimeter, and you see 16.7 watt. That is just fine. I do not want to crank it up more, and frequency is just fine. Let me go up to high, and let's see, and it is 40 40 watt on 430, and that is more than fine. We do not want to change it in any way. Great. Alright, meanwhile I have tested if our fan is working, and it is. So that is a good sign, and yeah, as you know, we have now here our ventilation holes, and I honestly hope that this will solve the problem, but I guess it will, because otherwise Yaesu wouldn't have done the modification with the X version. So I'm quite sure that you know, it is fine. Okay, so we have seen all the functions. So we have seen that our amplifier is working just fine. You know, that is what we wanted, and that is what the radio was in for. So we are definitely here at the end of our video, and once again I could adjust it to 50 watt output power, but I do not want. So it really does not make any sense, and therefore we leave it as it is for sure. I just want to yeah, I just want to make you clear that this kind of work really needs the right tools, and it really needs a little bit of experience. So if you are not sure that you are able to handle it, please don't try it. You really destroy more you ever can think about. So don't do it. So it is really a tricky job with this new MOSFET package. Alright, so that is the end of our video. I just put back here, of course, our housing, and then it goes back to the old man. And yeah, thanks for watching. Hope you enjoyed it a little bit, and if you enjoyed it, please give me a big thumb up, and catch you next time. Bye.